Uh, Now we'll start with one of the important chapter, that is probability. First, we'll learn the definition, uh, which we'll understand only after solving the problem. So don't worry. Probability is defined as the ratio of the number of favorable outcomes favoring the event to the total possible outcomes. Probability is often used to indicate a possibility or chance of an event to occur. I think it's confusing, no? Don't worry, you'll get to understand after solving some problems. Terms used in defining probability: a random experiment. When an experiment is conducted any number of times under identical conditions, and if the result is not certain and any one of the several possible outcomes, the experiment is called a trial or random experiment. By any random experiment, there is possible number of outcomes. So the possible number of outcome is called as sample space. Set up all possible outcomes. Suppose if your event is causing a coin, then the possible outcomes, it can show head or it can show tail. So the sample space is containing head and tail. The number of sample space will be 2. Suppose two coins is tossed, so the possibility is both the coin will show head. First will show head and next one tail. So first one is tail, second one is head, and both tail. That means number of sample space equal to 4. We can generalize by giving one formula. If n number of coins are tossed, then the number of sample space will be 2 raised to n. That means if 3 coins are tossed, the number of sample space will be 2 raised to 3, that is equal to 8. Suppose a fair die is thrown, so you can get the outcome as 1, 2, 3, 4, 5 or 6. So number of sample space is 6. Suppose 2 dice are thrown, so you can get 1, 1, 1, 2, 1, 3. You all are familiar with this, I know that. So the number of sample space will be 36. Now we'll see some types of events. Equally likely event. Equally likely means all can occur. There is no biased outcome. Suppose if you are throwing a die, that means it can show 1, 2, 3, 4, 5 or 6. Any of the 6 can come in the output. Okay. Mutually exclusive event and exhaustive event. These two are very important. Mutually exclusive, that means there is nothing common in both the event. That means A intersection B is phi. An exhaustive event is such that if you'll combine all the events, if you'll take union of all the events, you'll get again the sample space. For example, suppose a die is tossed and the sample space is S, 1, 2, 3, 4, 5, 6, and event A is 1, 2, event B is getting 3, 4, 5, and event C is getting 6. Hence, the event A, B, C are mutually exclusive because there is nothing common in this, and also mutually exhaustive because if you'll add these three, that means if you'll take union of these three, you'll get your sample space again: 1, 2, 3, 4, 5 and 6. So keep these two definitions in mind because they may come in the problem. Okay, so you have to remember what is mutually exhaustive and mutually exclusive and exhaustive event. Now we'll see probability. Probability PE of that event, probability of an event, is equal to m upon n. M is the number of outcome in the required event and n is total sample space. So you have to find the number of events. Okay, so you can find the probability. There is sometimes they called one event complementary event, which is shown by E bar. That means the complementary is n minus m, and if you'll add these two, probability of event and probability of complementary event, you'll get the addition as always equal to 1. So probability of E is also called as probability of success. Probability of E bar is also called as probability of failure. There is one term, odds in favor of E and odds in against E. So odds in favor of E means P probability of E upon probability of E bar, and odds against E is probability of E bar upon probability of E. Why I am giving these two terms? Because sometimes in the question they are giving these terms, odds in favor and odds against. So keep in mind, and the final formula is m upon n minus n. for odds in favor of E, and for odds in against C is equal to n minus m upon m. Now we'll see very simple example. To example, if two dice are thrown simultaneously, that what is the probability getting a doublet? Doublet when both the dice are showing same number. So you know that number of sample space is 36 in the case of two dice. The number of doublet is 1 1 2 2 3 3 4 4 5 5 6 6. The number of this event is equal to 6. So the required probability will be equal to 6 upon 36, that is 1 by 6. Now we'll see the next example. If 5 coins are tossed together, what is the probability of getting exactly 3 heads? Now we know the generalized formula for the n coins. So if 5 coins are tossed together, the total number of sample space will be equal to 2 raised to 5. That means 32. What is the probability of getting exactly 3 heads? The event of getting exactly 3 heads will be combination of 3 head and 2 tails. The number of arrangements with this combination is 5 factorial upon 3 factorial 2 factorial. This is the formula of combination. You all know about this. N factorial upon r factorial n minus r factorial. So there will be 10 such combination where you'll have 3 heads and 2 tails. The required probability is 10 upon 32, that is 5 upon 16. Now do not take tension. I'll not start playing casino. Okay. So sometimes they ask question priority based on the cards, so I'm just showing you the cards. I know you all are knowing this. Just take it as a revision. The A, they are called as ace, then 2 3 4 5 6 7 8 9 10. This symbol is called as spade, heart, diamond and club. So there are 13 spade cards, 13 heart, 13 diamond and 13 club. So if you'll categorize, there will be 26 black cards, 26 red cards. In 26 black cards, 13 spade and 13 club. In 26 red card, 13 heart and 13 diamond. That means there are total 52 cards. Now this is cards up to 10. After that there will be picture or face card. For every suit, these are called as suit. So every suit there will be 3 picture cards. King, queen and jack. King, queen and jack. So sometimes in the question they also ask the total number of ace. The total number of ace is 4. The total number of picture card is 12. 4 into 3. Total number of queen 4, jack 4, king 4. So keep this data in mind. Now the question: a card is drawn from a well shuffled pack of cards. Find the probability that it is a king, a black card, a spade. You know, if the single card is drawn, the NS will be 52. So a king, the first event is a king. You know the total number of king is 4. So the required probability is 4c1 upon 52c1. The answer is 4 upon 52. A black card, you know the total number of black card is 26. So required probability is 26c1 upon 52c1. Spade, there are 13 spade cards, so the required probability is 13c1 and 50 upon 52c1. It's very simple. Now we'll see some other examples. If 3 cards are drawn simultaneously from a pack of well shuffled cards, then find the probability of them being black. You know that total number of black cards is 26, so the required probability is 26c3 and upon 52c3, because we are choosing 3 cards. If 3 cards are drawn at random from a pack of cards, what is the probability that there are 3 cards are king, a queen and a jack? You know that there are 4 king, 4 queen and 4 jack, and they are all combined with AND operation. A king and a queen and a jack, because there are total 3 cards. So required probability will be 4c1 into 4c1 into 4c1 upon 52c3. Suppose it would have been or, so you have to add this. In place of AND you have to multiply, in place of OR you have to add. But in case of OR, just keep in mind there cannot be 3 cards. If it is OR, that means there is only 1 card in selection. Okay. Now we'll see the addition theorem of probability. Probability A union B is equal to probability of A plus probability of B minus probability of A intersection B. That means this is A, this is B, and this is the common part. So you have to find out the probability of A union B by adding these two A and B and subtracting this common region. Suppose these two events are exclusive events, that means there is nothing in common between these two events. The probability of union can be found out just by adding probability of A plus probability of B. Now we'll see a simple example. A card is drawn at random from normal pack of cards. What is the probability that it is either a diamond or a king? Uh, Please take a note of this. Diamond, the total number of diamonds card is 13 and total number of king is 4. But there is also common in this. There is also one king of diamond. Okay, so you have to take care for that. So probability of A is equal to 13 upon 52 because there is 13 diamond card. Probability of B is 4 by 52 because 4 king card. Now probability of A intersection B, the common in both, is king of diamond, that is 1 upon 52. So the final probability A union B is equal to probability of A plus probability of B minus probability of A intersection B, that is equal to 4 upon 13. So please take care that you have to find whether in these two events there is something common or not. So you have to use in those type of question the addition theorem of the probability. Now we'll see the next example. A bag contains 4 green balls and 5 yellow balls. A ball is drawn at random. Find the probability that it is green or yellow ball. These two events have nothing in common. They are disjoint events. They the A intersection B part is equal to 0. So directly the probability of A is 4 by 9. Probability is B is 5 by 9. So probability of A union B is equal to 4 by 9 plus 5 by 9 is equal to 1. Now we'll see independent events. Independent events, when there is no link between events, the occurrence of one cannot create any impact on the occurrence of second. So if the probabilities are suppose A and B, two independent events, so the probability of A intersection B is equal to probability of A into probability of B. We'll see one example to understand this. A bag contains 4 green ball and 4 yellow balls. Two balls are drawn in succession from the bag with replacement. What is the probability that the two balls are of different color? If A and B denote this event, so the probability of A will be 4C1 upon 8C1, same the probability of B will be 8C1 upon 4C1 upon 8C1. So to find out the probability of A intersection B, you'll just have to multiply. Remember here the word from the bag with replacement. Suppose if it would have been without replacement, so in the second case the number of sample space will be 7C1. So just keep this words in mind. Now we'll see the conditional event. If A and B are events of sample space S and B occurs after the occurrence of A, then the event of occurrence of B after the event A is called as conditional event of B. Given A, it is denoted by B upon A. The formula is this. We'll understand this by one example. If two dice are thrown simultaneously, then the sum of the numbers on them is 6. Find the probability that one is on any one of them. So NA is like 1 5 2 4 3 3 4 2 5 1 is equal to 5. This is the first event because the addition of both the dice is equal to 6. In this they have asked the event such that there is 1 on any one of dice. So this is the first possibility, this is the second possibility. So number of event of B is equal to 2, and if you'll find the NA intersection B, it will be 2. So probability of B under the condition A is happening is equal to 2 upon 5. Now we'll see some of the gate problems. Two policemen A and B fire once each at the same time at escaping a convict. The probability that A hits the convict is 3 times the probability that B hits the convict. If the probability of convicts not getting injured is 0.5, the probability of B hits the convict is. Here the probability of convict not getting injured is 0.5. So the convict getting injured will be 1 minus 0.5, that is equal to 0.5. That means P A union B is 0.5. Okay. Now PB is equal, we can assume PB is equal to X, therefore PA will be to 3X. So if we'll put these in formula, so PA union B is 0.5, PA PB, you know that 3X plus X, and PA intersection B is equal to PA into PB, because these two are independent events. So it will be 3x square. So it will become one quadratic equation. If you will solve, you will get 0.14 and 1.19. But you know that the probability cannot be greater than 1. So the answer will be called 0.14. Therefore, answer is A. Why? Because they have asked the probability B hits the convict, and we have assumed that B is equal to X. So the answer of X is 0.14. Now we'll see the next question. An automobile plant contract to buy shock absorbers from the two suppliers X and Y. X supplies 60% and Y supplies 40% of the shock absorbers. All the shock absorbers are subjected to quality test. The ones that pass the quality test are considerable reliable. Of X shock absorber, 96% are reliable, and for Y 32% are reliable. The probability that a randomly chosen shock absorber which is found to be reliable is maybe of Y is, you know that the X and Y types of absorbers are there, shock absorber. Supply is 60%, 40%, the reliability is 96% and 72%. So you have to multiply these two to find out the total. So the the reliability, it comes from X. The reliable shock absorber comes from X. The probability is 57.6%, and for Y it's 28.8%. It's because it's 0.288. So if you want to find it, it should come from Y. You have to divide this by the total of these two. So 0.288 divided by 0.576 plus 0.288, you'll get 0.334. So the probability is 0.334. So this is a very simple example. You can very easily solve. Just you can have a look again. You have to multiply these two to get these two numbers. Suppose it would have been the question of X, so you'll have to put 0.576 instead of 0.288. Now the next problem, it is very good problem. Okay, so please have a careful look at the solution. A and B are friends. They decide to meet between 1 p.m. and 2 p.m. on a given day. There is a condition that whoever arrives first will not wait for the other for more than 15 minutes. The probability that they will meet on the day is. Now we will solve this by graphical method. Because this is a integrational type problem, so the graphical way is very easy. This is graph. Line AC is that line when we are assuming that they'll come on time, same time, that is 1 p.m. One person can come on any time between 1 and 2. The second person also can come between any time 1 and 2. But what is the probability that they'll meet? If the first person comes between 1 to 1:15 and second person also comes between 1 to 1:15, so this is the shaded area where of the possibilities that they'll meet, otherwise they'll not meet. So you have to find out the area of this shaded region, nothing else. So the total area of this box minus the area of these two triangles, you will give the area of shaded region. Now you have to find out the sample space. You have to find out the sample space, or you have to decide the unit. So you'll have to decide the unit by minutes. So it is 60 minutes and 60 minutes. The total number of sample space, total sample space will be 60 into 60. That is 3600. So area of PQRS, that means the shaded region, will be equal to 3600 minus 2 into area of triangles. So the area of triangles half into 45 into 45. The final answer is equal to 7 upon 16. Since it is the problem of integral probability. So we'll not take the integration. We can easily solve using a graphical method. So this is one of the method. So if in exam it comes, then please take care that you can solve this by graphical method. Okay, there is no harm in solving like this. Okay, all the best.